Okay, so this video is about composite functions. A composite function is a new function that's composed from two other functions. The important thing to think about is the inside function and the outside function. The inside function happens first, and then the outside function happens to the output from the inside function. So we'll explain that in a minute. Let's get on to the whole what it is. So first of all, notation. Sometimes we talk about f of g of x. That's sort of old-fashioned notation. Often we'll just go with f of g of x, which is more modern. G of x is the inside function, f of x is the outside function. Now the order is important, so g of f of x would be g of f of x. So the order is important. Okay, here, let's have a look at this example here and see what we've got. So, function of x equals x squared, g of x equals x, 4 minus x. So we want to do f of g of x. That's what we're trying to find. So we start with f of x equals x squared plus x. And wherever the f of g of x, we're going to put g of x wherever the x is. So g of x squared plus g of x, which is g of x was 4 minus x squared plus 4 minus x. Now obviously we're going to expand that out, so that's going to give me 16 minus 8x plus x squared. That's my first bracket, 4 minus x squared. And then I'm going to go plus 4 minus x. And when I put all of that together, it's going to give me x squared minus 8 minus 9x plus 20. Okay, now the question that we should be asking ourselves, what about domain and range? So, what happens to the domain and the range? So let's have a look at these ones. Function of x, this one, x squared take 1, and g of x is 1 over x. And we want to find h of x, which is function of g of x. Now, first thing we want to say, well, let's consider the domain and the range. So let's think about, domain, range, and I'm going to have f of x and g of x. I'll just make this little table here, like so. Now, what do I know? X squared take minus 1, that's going to look quite, that's a quadratic, so it's going to have all real numbers as its domain, but it starts at minus 1 and goes up to infinity. So minus 1 on the y base and goes up to infinity. 1 on x sort of looks like a hyperbola. So it's all real numbers excluding 0, and all real numbers excluding 0. So the critical feature is the range of the inside function has to become the domain of the outside function. So when you do like the inside function first, the range of inside function has to become the domain of the outside function. Becomes the domain of the outside function. So how does that help us? In this particular case, g is the inside function. That has to be a subset of that. So does the function exist? In this particular case, we say, well, the range of G has to be a subset of the domain of F. So you say, is that a subset of all real numbers? Yes, so it does exist. Then you say, well, let's, what have we got? We've got f of g of x. So f of x equals x squared take 1. So f of g of x, g of x squared take 1. G of x was 1 over x take 1, which is 1 over x squared take 1. So our new function is 1 over x squared take 1. And you think about the domain for a minute, and you say, well, the domain of the new function, x, has to be the domain of the inside function, all real numbers, excluding 0. Gee, I'm not doing those brackets very well. So all real functions excluding 0. So let's think about that. This is what we're really trying to say. Does the function f of g of x exist? Well, for the function to exist, the range of the inside, well, that should say function, the range of the inside function must be a subset of the domain of the outside function. And you can see I've got written that there. In this case, the range of g of x must be the subset of the domain of f of x. In general, the range of the inside function must be a subset of the domain of the outside function. Okay. So let's look at this one here. The inside function, we want f of g of x. Does the function exist? So again, I'm going to look at domain and range, and I'm going to look at f and g. And I just do a little table here just to make sure that it all works. Does it exist first? So the real function, square root graph, is going to look something like that. So it's real positive union with 0. And the range is going to be real positive union with 0. I'll look at 2x take 1 is just a straight line. So it's going to have all real numbers. So for this to be true, f of g of x, I need all real numbers to be a subset. So the range of g has to be a subset of the domain of f. So is R a subset of all real positives union with 0? No. So f of g of x does not exist. The next question you might ask, does g of f of x exist? So what about, g of f of x? Well, all real numbers, undo that. This time I'm saying that real positives are subset, so are real positives. So this time I'm saying the range of f, a subset, is the range of f, a subset of the domain of G. So real positives union with the set of 0, is that a subset of all real numbers? Yes. So G of f of x does exist. Now, if it does exist, then we can find g of f of x. And how do we do that? Well, we start with g of x equals, now I've forgotten my two functions here, 2x take 1, 2x take 1, and then I'm going to put f of x wherever the x was. So 2 times f of x take 1, and f of x was the square root of 2 times the square root of x take 1. And what's the domain of that? Well, the domain of the whole thing is the domain of the inside function. So the domain of f of x in this case, which was real positives union with 0. Or if you like it in interval notation, including 0 up to infinity. So to summarize, what does that look like? The domain of f of g of x is the domain of the inside function g of x. The composite function is defined if the range of g of x is a subset of the domain of f of x. Now, sometimes we actually restrict the domain of the inside function so that the range of the inside function is a subset of the domain of the outside function. Okay, bye.